Japan is known for its unique arcade culture. One of the most iconic rhythm games here is Taiko no Tatsujin. Fast beats, intense rhythms, and pure fun. But what if you could experience something like this on your web browser, or better, on your VR headset? In this video, I will explain the most important and interesting parts so you can build your VR rhythm game. Before starting, if you are new to 3D web development, discover my course, React 3 Fiber, the Ultimate Guide. With project-based lessons, you will quickly grow your Three.js and React skills to be able to transform the ideas you have in mind into 3D web applications. To have a Three.js with React 3 Fiber project up and running, we'll be using my template, R3F Bit Starter. You can simply clone it, you install the dependencies with Yarn, and to run it, Yarn dev. You will have a default cube with camera controls, perfect to get started. The first thing we want for our game is to create an environment, a scene where we can play. I found this nice skybox on CG Trader, which is free and royalty free. You can download it and it's directly a GLTF file. We can simply add it into our scene with GLTF, and we now have our skybox ready. Then to find good looking models, I've been to poly.pizza. I've searched, for example, Tori, and I've chosen this Japanese Tori from Jacques Foury. I've also searched for different trees to create a composition. In Blender, I adjusted the colors and created this stage. Nothing fancy, just with my beginner Blender skills. Feel free to do much better. Let's load it inside our project and get rid of the default cube. And we have our gaming environment. Not the perfect one, but still it's good looking. To make it look a bit more immersive, don't forget to add a light and to cast shadows, or you can also bake lights in Blenders, it's up to you. And you can see the nice shadows from the tree and the Tori. Next thing is to have instruments to play on. I was looking initially for taiko, but I didn't find the perfect ones, so I found this nice drum that I chose. Let's load them. Instruments. I run GLTF JSX to generate that component and have the GLTF accessible. And I added an extra prop, the color, to be able to change the color of the material. Now you can see that the left drum is purple, the other one is green, and the crash has its own color. What I don't like about this model is that it is really flat. It's low poly but look way too flat. So what I decided to do is to pimp a bit the model. So I loaded it inside the Blender and to use the Blender plugin named SimpleBake to bake the ambient occlusion. I won't show you the entire process of baking with SimpleBake, but it's pretty straightforward. And if you ask me, I can make a video tutorial dedicated to this. Just know that it is pretty simple. First of all, let's talk about what is ambient occlusion. If you look currently, everything is flat. It's the same color based on the orientation of the light. The ambient occlusion is based on the geometry, on the shape of your object. Even with an ambient light, the light will reflect differently based on the shape of the object. It's like if you look in the room, in the angles, even if it's flat, you will see that you have a lit shadow. Here is what the ambient occlusion texture look like. You can see we have nice gradient, nice shadows. And instead of representing the color, I can load the image texture to our object so we can visualize it. So this must be this one. You will see that the effect is subtle, but you can see some different of colors here. But it's not a color map, it's an ambient occlusion map. So we keep the color, and to export the ambient occlusion map with your material, you just do GLTF settings. So it's what we see here. And then you import an image texture. You select the texture you want, attach it to occlusion, and when you will export with Blender your GLTF, it will be here. So now instead of using our basic drum, we load the drum with ambient occlusion. It's a separate model. If you look at it, you can see it's way less flat around the edges. Now we have our instruments we want to be able to play. So I created a new project with Logic Pro, a music software. Then I looked at the sound bank, what instrument can I use? And I decided to use percussion ones and UIKit. For the moment, we just want the different sound we can use. So we can create a MIDI region. I will explain what is MIDI later. On the piano roll view, which is this view here, you can see each note is assigned to one song. So I tried a few of them and decided which one I want to use. I've chosen this one for the crash, for the big taiko, this one, and for the medium side, this one. Then I simply exported each sound independently to have it available. This is the sound you can see here, taiko crash.mp3, middle and side. Here in the drum component, it's only the visualization of our instrument, nothing related to the logic of playing music. Instead, in instrument, I created a drum collider. Initially, I was thinking about using physics, but even in VR, we can use the pointer, the intersection between our pointer and the mesh. So let me show you the colliders we are using. So true. And the white zone is the zone when our cursor interacts with, it will play sound. You might wonder why it's so big compared to the actual size of the object. It's because in VR, if you play with the stick, when you come back up, it would play again. I could find other solution, for example, to look the direction it's going from top to bottom, but the simplest one was just to keep it big. In the experience, I just made a use effect when the component is mounted, because it's one of the main components, to register on key press S, D, E, F for the different keys. Why are those keys? Because I know that in QWERTY and OtherT, both will be the same. That's a lazy solution. To indicate the users the key, we can add those nice looking elements. So our user have nice visual indicator, they can do it. But let's get rid of the collider. Okay, better. Now we can try to play. The sounds are playing. But how does it work? For the main global state, I'm using the store management solution named Justin. So I created a global store accessible from the whole game. Because the game is not yet too big, I could just store everything in the same one named use song. So I created this big hook responsible of literally everything. If you look at this section of the store, you can see the logic to play note. So first we have a function we call play note to trigger the play of the note, which is the on key press or the collision with the instrument in VR or with the mouse. And we have play note function and set play note function, which is to be handled in a separate component. And what play note does is to call the play note function. And you might be wondering why I'm not playing the audio here with new audio and play. It's because I wanted to be able to play the same note repeatedly fastly. Let me play the crash multiple times. I hope it won't break your ears. The sound is always the same and it's stopping the previous one to start the new one, which sound not very realistic. So what I did instead is to use the positional audio component. Let me explain it to you. Instead of having one audio source playing the same sound and stopping and pausing every time it played again, I'm using 4 positional audio sources. So this one, this one, this one, and this one. Because I'm using positional audio, they are positioned in a 3D space. And based on the index, it's going from left to right and from close to you to far away, better for the immersion using VR. So I'm using a second concept named round robin. Instead of always playing the note on this one, the first time it will play this one, then this one, which is at a different position, then this one, and by alternating like this, you have a slight variation, making it less flat. So I reset the polyphony to 4, and if I play the crash repeatedly, it will both break your ears. But you can feel it's specialized, it's rotating around you. And same for the snare. Okay, so now we have our scene, our instruments, we are able to play. What we need more is to be in VR. I'm using the React 3 XR library from the creators of React 3 Fiber. These guys are literally the best of the world. And it's a bridge to use the WebXR API available on your web browser from your desktop device if you have a VR headset connected to your desktop or laptop, or directly in the web browser of your MetaQuest headset or Apple Vision Pro standalone headset. Me, I will be using a MetaQuest 3. I recommend you when you develop to buy a different head strap because you will put it a lot, remove it a lot, and it's better if it doesn't ruin your face. But even with it, it will hurt. Just be prepared to suffer. So once you have installed the library, what you need to do is to wrap your whole scene inside an XR component with a store. And when you create the store, you can add different settings. You can have a default controller, but us, we want to visualize our drumstick. So I created a drumstick component. Inside, it's just loading a drumstick mesh. And because it is attached to the controller, it will follow the hand position. But because it is custom, I need to add manually that we see the source ray pointer. But it is a component available in React 3 XR library. This is the light pointer you see to be able to aim at buttons. Then by default, when you start the VR AR session, you will be at 000. So you can change it by changing the XR origin. And you can also update its value if you want to move your character in a 3D space. Everything is pretty well explained in the documentation. You have all the components, all the hooks to know what is available, and you even have a few examples you can reproduce to learn it. But something important is to try your project on your headset. So if, like me, you are using a Quest 2 or 3, you will need to download the MetaQuest Developer Hub. You can set up your device. Me, it's already set up, but it's not connected. So let me try to connect it. Here it is, and it's detected. So once it is detected, what you need to do is to run custom commands. The command you will need to run is to be able to connect to local host of your desktop, laptop, directly from your headset to have access to local hosts. In this case, because I'm using React with Vite, it's 5173. For Next.js project, by default, the first one will be 3000. This is why I have two custom commands, localhost, which is this one, 5173, and localhost 3000. And the command I've set up, if I modify it, it is ADB reverse TCP double dot with the port and TCP double dot with the port to create the connection on your Android device, which is the Quest, and your device, laptop or desktop. Once you are connected, you hit run. You will need to do it every time you disconnect, reconnect your device. And after that, you will be able to directly access your browser on your headset. But before being able to test it, we need some button to enter the AR or VR mode. Because our application, we will run it inside the VR. We won't have access to the UI element that are in HTML, CSS that you see here. So what I wanted is a solution that worked for both the desktop and for the 3D space. So I wanted my UI to be in 3D. I could create some meshes myself, add some 3D text inside it, or even 2D text. But Andres, the creator of React 3 Fiber, also created a library named UIKit. This is exactly meant for this purpose, to build 3D user interface. And the idea is to have a syntax close to what you have using HTML, CSS, but it will do all the calculation for you. It's like an HTML, CSS renderer, but for 3D and with additional parameters, but also a few things that are not available. You can create your own components, but they provide two libraries, the default one based on ChatCDN and Apple inspired by Apple Vision Pro. This is the one I chose. By simply following the documentation, I ended up creating my UI with responsive element and also the ability to make flex direction. This is how I created the UI component. So it contains a card with the logo, some text, and then a flex container with 3 different songs I prepared, and a button to switch between VR and AR. If you run it into your headset, this is what it looks like. But luckily, even if you don't have a headset available right now, they provide an emulator, Eware Dev UI, that is included by default when it detects it is localhost. If it doesn't automatically work for you, they say you can use this shortcut, Window or Command, Alt or Option, and E. To be able to start your AR or VR session, you need the store that you created at the beginning. And then when you click on your button, you will call either store.enter AR or VR. Me, I decided to start always in AR. If we try it, VR AR, so it's loading the emulator. You can move the camera with the play button like this. We can play the audio and you can see that the hovering is working. So if I click on pass through, it will remove the background behind. Because I'm not on the headset, it won't work. And what it does is in my store, it will change the pass-through mode or not. Now we can check if we are in pass-through mode. We will hide or not our skybox. Let's try it. And you can see now we have the white background, but if you are on your headset, you will see your environment if AR is available for you. You can also use XR hook to know if you are in immersive AR, if you are in VR or not, to know your current state. Again, the documentation with all hooks and all components available. Because we are looking for good performances, by the way, I prefer the background. Currently, it's looking at the intersection always through all object. And this is what is used on our drumstick to detect collision. But to get better performance, you can use the nice component BVH from Dry. What it does is it speeds up raycasting exponentially. So easily done. You wrap your experience with BVH. And because we don't need depth intersections, we can just set up first hit only. Now we have a good base ready. We want to be able to play songs because we just don't want to play instruments as a standalone. At the beginning, I was a bit crazy. I was thinking to make like in this existing Taiko game in VR. And by the way, it's lovely. And to create a song builder editor, which is something still doable in what we created, but it's a lot of work. And because I don't plan to sell it to you around 10 euros, I've chosen a simpler solution. I decided to write MIDI files. So we have used this software, Logic Pro, to just generate our different instrument sounds, but I also use it as a music editor for our game. So what I did is I downloaded a song online. I'm using the royalty-free songs found on Audio Stock, but it requires a paid subscription or to buy the songs individually. I have a yearly paid subscription for the YouTube videos, so the song is coming from here. And then with the same instrument kit, I wrote a MIDI timeline with the notes we can play. So you can see we have the 3 notes we discovered earlier. And in the piano roll, I can write the song. So let's try it. This is how we write the song. You can edit here, then export the MIDI file and import it in your project. And because MIDI files is a common file format for music editing for software instruments, I'm using Logic Pro because I used to play music and it's a paid software, but you have free MIDI editor online you can use that will generate the same type of file. And because it is a standard type of file, I'm using the library Midi from Tonejs to convert the MIDI data into JSON. So you have the documentation, they show you how to do it. What we do is in the UI, when we call load song, we will load the audio file, the MP3 format, which is the original file from Audio Stock. And with the MIDI library, we will load the MIDI file to get the data in JSON. Maybe I can console log what we have, console.log MIDI. And here is what we have. We have the MIDI file, the header. So you can see you have the tempo available. So if I made some tempo change or the music require it, I would know when it happened to be able to accelerate the note speed and so on. Then you have the tracks. So us, it's only UIKit and all the notes available. You have the MIDI note. So we only have 3 notes, 45, 38 and 57, which are these 3 notes you have here. The velocity, we are not using it, but it's to detect how strong it must be played. It's something we can use. Then you have the ticks to know when it is happening and the duration ticks. Because it's percussions, we are not using it. But if, for example, you want to create a piano game, you will need to have it to know how long you need to press the key. Now we have our song loaded. We want to display the notes and to be able to play them. So we have 3 different types of notes. We have the purple ones, we have the crush one that are yellow-orange, and we have the green ones. So because with the Midi file, we know the ticks when they are starting, we are able to represent them on the depth axis, the z-axis. But instead of having a use frame that would animate all of them one by one, and to be very costly in terms of performance, they are all within a group with their position, and it's the whole group that is going in the right direction. This way, if we detect a tempo change, we would be able to speed up or slow down the notes without having the hundreds of notes handling the logic. Here it is, we have the notes component that contain instances to render the same mesh of each note individually without creating a new render call, and to have better performance because each note is representing exactly the same thing, which is this rounded cylinder I prepared in Blender. That's why the GLTF is loaded inside nodes in plural, and then it's used on the instances. And each node, it's only responsible to display the instance, and at the very beginning to assign its position based on which node it is. So we have this function getNodePosition, and based on the time of the node and the duration of the node, we will know where in the song it's supposed to be, and we define a timeline size which contain all the nodes, which is our main group container. Let's try it, and we can see the nodes are positioned correctly. Now we want to detect that when we press a key or play a note, it's played at the right time to update our score. You can see that I made something a bit weird, which is register on not played and unregister on not played. And then in on not played, I'm doing the logic for each note. We will see it right after. But I used register and unregister note because it's also something that we will use to display some effects when we are playing notes. But first, let's have a look at how we detect if a note is correctly played or not. Basically, what we want is we have that sweet spot here where the note should be played, and we want to detect it's played at the right time, but we can't expect the person to play it at the perfect tick. So what we are doing is, if we detect it's within this range, slightly before or after, it's perfect, just a few milliseconds. If it's a bit more within this range, it will be good. Then if it's more, it will be okay. Then if it's not played or too far, it will be considered as a missed note. Same if instead of pressing this note, you are pressing this one at the wrong moment. This is the logic that you can see here with the different times, with 0.1 second for perfect, 0.2 for good, 0.3 for OK, and above it will be a miss. This loop is happening when we play a note, but we have a second loop, for example, the player is not playing, in a use frame that is only responsible to check if we missed a note. And then we will call our update score with if it's failed or if it's a good. Now our score will be updated. We can display our scoreboard and try to play. Let's try it. You can see that I played a lot because I did a lot of perfect, but you can see I also made some miss and good. Before making it a better experience, let's have a quick look at the things to improve the performance of the game. First of all, to debug it, we can check if we are in localhost and display the stats component from dry. So we have the frame rate on the top left to see if we are not doing things hurting performance. Then something very important is on-click events when you have functions as prop parameters. To avoid that it recreate it at every re-render, you create a function, for example, on-click will be on-exit, and you wrap it in a use callback. So it's not a new function, it's using the same, and it won't recreate, re-render the component every time the parent re-render. You can also leverage use memo or memo to memoize some components to be sure they aren't re-rendered. Now we can focus on making it a more enjoyable game, a more immersive one. On the instrument, we can display the same mesh that we have for the note. So this way, we will be able to see when it's exactly expected that we hit the note. This is now the transparent thing you see on top of our instruments. For the thumbnail of the song, I've been using Rock, but you can use any AI you like, paid services or free ones like Comfy UI with Stable Diffusion. To make the experience better, I've prepared a combo component, which contains the current combo and 2 dancing avatars, with the avatars coming from my avatar character configurator. If you haven't, I recommend you watch the video. And based on the current combo, we are displaying a different dance. So if we are not having a combo, we display happy idle. Then when we reach 10, we will play the hip hop dance. Then 50 is house. Swing is 100. And if the song is over, we'll display victory, which is just an animation with the arm on the top. Let's see what we have so far. You can see the dance changed. The experience starts to be very good, but there is one thing that is lacking. It's the feeling you are really playing the instrument and hitting that note. This is why we have register or not played, which is to register functions to be called when a certain note is played. So we have an array containing all those functions. And when we play a note, we also call all of those event handlers. Basically, it's like when you do window.add_event_listener on click or anything. And this is what we use inside our instruments. So our instruments, they are wrapped inside a bouncing item with which note it's expecting. So for the crash, the note value will be crash. And when we register the note, what we will do is we will use uSpring to animate the scale value. And with the API, we will be able to animate it. Now, if we play a note, we have the feeling we are hitting it. With the keyboard, it's nice, but in VR, it's way better to feel we are hitting it. So we just don't hear only the sound, but we also visualize it. That gives me the idea I could have added vibration when we hit it. And then to make it very convincing, I've created some explosion particles. So only when we successfully play a note and it's not a miss, we will add an explosion. In our explosion particles component, responsible to display those explosions, we'll have instances, plane geometry, which is the representation of our particle, and the standard material. Then each particle of our explosion, it will have a speed, an angle, a size, and a lifetime to create this explosion feeling. Based on that, each particle will adjust its position around the lifetime. Let's see what we have. So we have those squares representing an explosion, but we can do better. Instead of just having the color of the note, purple, green, or yellow, I've created an adjusted color. What it is it's taking the color and it will multiply it by a random number to make it brighter or darker. But also, instead of just representing a square, we can add a texture. So the idea I got was to display musical note. So I took the SVG, then I imported it in Figma, turned the color to white and sized it to 2424. And inside our explosion particle, we'll use this as an alpha texture. By doing that, everything that is white will be visible, but all the rest will be transparent, displaying our square for the particle as a note. Let's try it. Way more convincing. I have a lot more ideas to put into the game, but if you want to join the journey, practice and try it, you can create pull requests on the repository and we can achieve great things together. We can, for example, add new songs, which isn't too demanding technically. At the end of the song, we could send it to a server to display the best score, enhance the stage at some different level of difficulty, and to enhance the VR, AR, or even the mobile gameplay. But now it's time to play. Thank you for watching, I hope you enjoyed this new type of video tutorial. If it's the case, don't forget to hit the like button. Please share your feedback in the comments section, it will help me provide you the best content. Don't forget to subscribe to not miss the upcoming video tutorials. To continue your learning journey, watch this video available here.